All right, next step in our process, writing recursive and explicit formulas. And we're doing this from a word problem, so let's read through this. It said, the money that Ronald has in his savings account earns interest each year. He does not make any withdrawals or additional deposits. The account balance at the beginning of each year is $10,000, $10,300, $10,609, and $10,927.27, and so on. Write a recursive formula and an explicit formula for the sequence. So we're asked to write a recursive and explicit formula for this sequence. Now let's take a look. So what is our sequence? Well, our sequence is right here. We got this $10,000, $10,300, $10,609, $10,927.27. Well, I might want to check to see if it's arithmetic or geometric. Let's see the difference between 10,300 and 10,000. Well, that's $300. Change colors here. But the difference between 10,609 and 10,300 is 309. So it doesn't appear to be arithmetic. So let's take 10,300 and divide it by 10,000. So I got my calculator out, and that comes, I think, to 1.03. And let's see, let's take 10,300 and multiply it by 1.03. See, make sure we get 10,609. And we do. And let's see, take 10,609, last check, times 1.03. And it does equal 10,927.27. So my common ratio, this geometric sequence, is 1.03. Now, so first I want to think about, I'm going to write a recursive geometric sequence. Now, my basic formula is that I got AN equals my common ratio times A to the n minus 1. So if I'm going to write this, the first thing I have to do is define what A1 is. Well, A1 is $10,000. And then we're going to write the recursive formula, which is I should put AN equals 1.03 times A to the n minus 1. All right, that looks good. If I were to find the second number of the sequence, A2, I'd plug in 1.03 times 10,000. That's going to get me to 10,300. And then lastly, I need to define my domain, which n is greater than or equal to 2. All right. Now we're going to do the same thing, except this time we're going to write it as an explicit formula. And our basic format for an explicit formula is AN equals A1 times the common ratio raised to the power of n minus 1. Well, we're just going to plug and chug this thing. So then we would have AN equals, we're going to substitute $10,000 for A1, and that's going to be times our common ratio of 1.03 raised to the power of n minus 1. And there we go. We have written recursive and explicit formulas for this scenario, given Ronald and his $10,000 and his annual interest earnings, not compounded. The compounding would put a little twist on it. And we've written recursive formulas and explicit formulas for this sequence. I love it.